Here we have a SAT math question. Okay, let's go the information. If x less than y and negative 3x greater than y, which of the following must be true? Okay, here we have four answer choices. Since this is a digital SAT, we can use Desmos graphing calculator to solve this problem. Okay, now let's go to Desmos graphing calculator. Here we have Desmos graphing calculator. Okay, now what I'm going to do is I'm going to give these two inequalities as the inputs. Okay, now let me give the first inequality x less than y as input. That is x less than y. Okay, now I got the graph of the first inequality. Now let me give the second inequality as input. That is negative 3x greater than y. Okay, now I got the graph of the second inequality. And so here, this region over here represents a graph of x less than y. And the region over here represents a graph of negative 3x greater than y. And this is a common region for both the inequalities. And also here for both the inequalities, I am getting a dotted line over here and here. So because here we have less than sign, here we have greater than sign. If I have less than or equal to or greater than or equal to, I may get a solid line. Since we have less than and greater than, I'm getting a dotted line for both the inequalities. When I get a dotted line, so the points on the dotted line cannot be considered. So if it is solid line, all the points on the solid line can be considered. But here we get a dotted line for both the inequalities. So the point on the dotted line cannot be considered. And now let's consider the point of intersection of the two lines. That's over here. That's origin 0, 0. Since we have the point of intersection on both the dotted lines, even we cannot consider this point as solution. So because it's on both the dotted lines, that is x equals to 0, y equals to 0, cannot be considered as a solution for the given system of inequalities. Okay, now what we have to do is we have to check the answer choices one by one with the common region we have over here. Okay, now let me consider the first answer choice, that is answer choice A. We have x less than 0. So let's check whether it works with the common region we have over here. Okay, now let's consider the values of x in the common region over here. All the values of x in the common region over here are negative. That is, all the values of x in the common region are less than 0. So clearly, the stuff we have in answer choice A is correct according to the common region we have in the graph over here. So answer choice, x less than 0, that is answer choice A is true. Anyways, we can verify answer choice B, C, D also. Like now let's consider answer choice B. We have y greater than 0. Okay, so if we consider common region, the values of y, both positive and negative. For example, if we consider a point over here, what is the value of y? So y is 4 over here, that is y is greater than 0. Okay, now let me consider a point over here. What is the value of y? The value of y is negative 2, that is y is less than 0. So in the common region, we have both positive values and negative values for y, but answer choice B says y has to be greater than 0. So this is not true. That means like we have to understand that always y has to be greater than 0 according to answer choice B. That's not true because we have both positive values and negative values for y in the common region. So we can reject answer choice B. Okay, now let's go to answer choice C. So probably answer choice C and D must be wrong because already we got that answer choice A is true. But we need to prove that the answer choice C and answer choice D are wrong. So for that, what I'm going to do is I'm going to consider a random point in the common region. Okay, let me take the random point over here. That is negative 1, 2. So at this point, the x coordinate is negative 1 and y coordinate is 2. So now what I'm going to do is I'm going to substitute this point into the inequality in answer choice C. So that is I'm going to plug in the x coordinate negative 1 for x over here. Then I'm getting absolute value of negative 1 greater than, and the y coordinate 2 for y. Then I'm getting 2 over here. So the absolute value of negative 1 is just 1 greater than 2. Clearly, this is false. So because we know very well 1 is less than 2, but here we are getting the result 1 is greater than 2 when I plug in this point negative 1, 2 into this inequality. So if I want the inequality over here is true, so it has to be satisfied by all the points in the common region we have in the graph over here. Even if one particular point does not satisfy this inequality, we have to say this is false. So the inequality we have in answer choice C is false. So we can reject this one. Okay, now let's check answer choice D for the same random point over here, that is negative 1, 2. So now we can plug in this point into this inequality in answer choice D. That is, we can plug in the x coordinate negative 1 for x over here and y coordinate 2 over here. So evaluation of negative 1 square is just 1 greater than 2. Again, it's false because we know that 1 is less than 2, but here we are getting 1 is greater than 2. So this is false. So this inequality is not satisfied by the particular point negative 1 comma 2 in the common region. So as I said for answer choice C, so if I want this inequality is true, so it has to be satisfied by all the points in the common region we have in the graph. Even one particular point if does not satisfy this inequality, then we have to say this is false. Since the particular point negative 1 comma 2 in the common region does not satisfy this inequality, we have to say this is false. So answer choice D is also false. So among the given answer choices, the only answer choice that is A is true for the given two inequalities over here. So the correct answer choice for this question is A, x less than 0.